All right. So what we're looking at for this video is what is called a z-score. A z-score is going to tell us how many standard deviations away from the mean our data point is. Yeah, I said data for you guys. Data. Okay? So all a z-score tells us how many standard deviations from the mean. Okay? The reason why we need this is because not all of our points are going to be exactly 1, 2, or 3 standard deviations from the mean. Let's take a look at this first example and see what we're talking about here. So if I have an average of 150, we know that that goes in the middle. And then we have a standard deviation of 25. So we can set this up as 175, 200, 225. 125, 100, and 75. All right? We know the breakup here. We know that this is 34, 34, 13.5, 2.35, and 0.15. All right? And down here. All right. So the question, let's say, I want to know how or what percentile am I in? How many people did I score better than if I scored a 190? The problem is here, my 190 is somewhere in this general area. But that doesn't necessarily split that into a nice percentage, and it's not a perfect 2 standard deviations away. So I know it's going to be less than the 97.5%, but I don't know exactly that percentage. I can't find that percentile. So that's when a z-score can come in and help us. Okay? In our next video, we're going to talk about how we actually interpret that z-score. We're going to have to use either a chart or a calculator. So this year we're going to go ahead and just use our chart to find our percentiles, but we can find the z-score really easy. Okay? Our formula for our z-score is going to be, we're going to take our data point minus our average or our mean and divide that by our standard deviation. And that is going to give me my z-score. When my z-score comes out as a positive number, that means that I'm going to be so many standard deviations above the mean. And if my z-score is negative, I'm going to be so many below the mean. Okay? So we can take that 190 now to get the z-score. That's going to be 190 minus 150 divided by 25. So 190 minus 150, that's going to give me 40 divided by 25. They're both divisible by 5. So that's going to give me 8 over 5. Divisible by 5, right? Yeah. So that's going to be 1.1 3/5, so that's double it, 60, 1.6. Cool. Okay, so let's see what that is. So my z-score is 1.6. That is telling me that 190 is 1.6 standard deviations above the average. And here we can see, here's 1 standard deviation, and here's that 0.6. So we didn't make it to 2, we're at 1.6. And the chart can then tell us that percentage. Okay, so we got another example here with the SAT scores. So the average is 1026, standard deviation of 209, and then a score of 110. So my z-score, I'm just going to take my data point minus the 1026 and divide that by 209. And just to save my brain for a little second, I'm going to go ahead and just plug this into a calculator, because that's fine. Come on, calculator, I know you're low. There we go. All right, so 1100 minus 1026 divided by 209. So this one is about 0.35 standard deviations above the mean. So this isn't even 1 above. So even if we were looking at a normal curve, here is our median, here's 1 standard deviation above. We only made it about that far to find our percentage. Okay? And the cool thing with z-scores is it helps us compare data that doesn't have the same scoring points. So let's say we were to take the SAT and then the ACT, we could compare our percentiles, our z-scores, versus comparing our scores from the SAT to the ACT, because they don't match up, right? Showing that I got a 32 versus a 1026, what does that even mean? So we take it to a common ground, which our z-scores and percentiles do. Okay, I'll be back with another video to show us our chart for z-scores. And yeah, that's it. See you later.